Hello friends, in this video I'd like to solve the following problem from the Croatian Mathematical Olympiad, 9th grade 2003, problem number 4 from combinatorics. How many positive divisors are there of 30 to the power 2003 which are not divisors of 20 to the power 2000? Nice problem from combinatorics. Here are my solutions. Here are my hints. First, notice that if you have a prime factorization of p1 to the power alpha 1, p2 to the power alpha 2, and so on, p1, p2, and so on are different primes, then this number has alpha 1 plus 1 times alpha 2 plus 2, and so on, times alpha s plus 1 positive divisors. Why is that? Because when you construct a divisor, it must have the same prime numbers raised to some natural powers. And these natural powers are from 0 to alpha 1, for example, for the first p. So we have alpha 1 plus 1 options, and so on. Then we have alpha 2 plus 1 options, so we can take p2 to the power of 0, p2 to the power of 1, and so on. 30 and 20, they have obvious factorizations. And finally, consider two cases separately. First case, so let D be a divisor of 30 to the power 2003, and consider separately cases when 3 divides D and when 3 does not divide D. So give this problem a try, and I will see you in just a minute. Okay, so here is my solution. As I suggested, 30 to the power 2003 is 2 to the power 2003 times 3 to the power 2003 times 5 to the power 2003, and moreover 20 to the power 2000 is 2 to the power 4000 times 5 to the power 2000. Very well. And now let D be a positive integer, and let it be the divisor of 30 to the power 2003. We have two possibilities. First possibility is easier. First case, when 3 divides D. How many divisors are, and notice that then obviously D is not divisor of 20 to the power 2000 because it has no 3 in its prime factorization. So we are just now counting. So our second condition is automatically satisfied. So now we are counting how many divisors are there of this number which are divisible by 3. Well, how many divisors? There are, well, 2 appears with power 2003, so we have 2004. 3 appears with power 2003, but remember, we cannot have 3 to the power of 0. It must be 3 to some natural power. So we're multiplying by 2003, and 5 can have any exponent whatsoever. So times 2004. So there are that many divisors D. It was easier. Second case is when 3 does not divide D. Then, notice that then, let's take a look. Well, no matter the power of 2 which we take, here we have always greater power of 2. So the only possibility that this number D does not divide 20 to the power 2000 is that we have higher power of 5 than 5 to the power 2000. Then D does not divide 20 to the power 2000 if and only if 5 to the power 2001 divide D. Okay, so how many divisors of this type are there? There are how many? Well, power of 2 doesn't matter. We can take any power of 2 which we like. What about the power of 3? Well, it must be 3 to the power of 0, so we have just one option. And this condition must be satisfied. How many powers of 5 satisfy this condition? Well, the exponent of 2001, 2002, and 2003 are good. So we have just 3 options. Divisors D. These cases were disjoint, so now we just need to add these numbers. In total, there are 2004 times 2003 times 2004 plus 2004 times 3. Let's call them good divisors D satisfying our conditions. And what is this number? Well, it turns out to be pretty huge. This number right here, it is 8 billion 44 million 86,060. So that is our result. How many divisors are there? That many. Many. Okay, and that's it. So thank you very much for watching, and I will see you next time. Goodbye.